In this chapter, we're going to talk about networking. For first few videos, we're going to focus on some of the theory of networking, and then we'll jump into programming. First of all, what is a network? A network is nothing but a bunch of interconnected devices or nodes. When I say a node, it could mean a PC, or it could mean a server, or it could mean any network component, for example a router, a switch, or a hub, etc. And when all these nodes communicate each other by sending data between each other, that's called networking. In this video, we're going to take a look at some of the key elements of a network. First of all, let us talk about a hub. Let's say that you have two computers in your network, say 1 and 2. Now you want these two computers to talk to each other. So you're going to install a cable between these two computers and they start communicating. Well and good. Let's say you wanted to add, say, 4 more nodes to your network. Now each and every node needs to be connected to each and every other node so that any node can communicate with any other node. So 1 needs to be connected to all the rest of the nodes. Similarly with 3 and 4. That's going to create a lot of mess. Especially say that you have 100 computers in your network. That's definitely not pleasant. So this problem can be solved with a hub. A hub is going to sit at the center of the network, and all the devices will now connect to that hub. And hub is going to take care of diverting the traffic or sending the data between the nodes. Now let's say that you wanted to send data from node number 1 to node number 2. So the data will be split up into packets. Now what is a packet? In network, you can't send a huge chunk of data in one go. It has to be split up into more manageable pieces called packets, so that all the network components would work efficiently to deliver the data to the destination. Now once the packet reaches to hub, it's going to create multiple copies of that packet, and all the copies would be sent to all the nodes in the network. Even the node 1 wants to send data to node number 2, the hub is going to send it to all the nodes by creating copies. That's because hub does not have any intelligence on where the packet is coming from or where the packet wants to go. Now this is again very inefficient. Although this has solved the problem of creating a lot of mess, this is going to cost a lot of bandwidth, because where hub is going to deliver packets to all the unintended nodes in the network, and is also a security risk. Added to that, hub is going to use a mechanism called half duplex, which means it can either send the packet or receive the packet, but not both in one go. It can't do both the jobs simultaneously. In case of high traffic networks, it's going to create something called a network collision, and that's going to create some inefficiencies. Surely a problem. So hub is not the best option we have. So how do we solve this problem? We're going to introduce something called a switch. Unlike a hub, switch is going to have some level of intelligence about where the packet is coming from and where the packet wants to go. Just like hub, the moment the switch receives a packet from, say, node 1, it's going to create copies and is going to send it across all the nodes in the network. But now switch is actually going to keep track of where the packet is going. It notices that packet didn't reach to node 3, 4, 5, 6. It has reached successfully to node number 2. So now switch will take a note of it in a table, node number 2 and its associated MAC address. What is a MAC address? MAC stands for Media Access Control. It's a unique physical address associated with each node in the network. Whenever a packet is sent from node number 1, the packet has to have some information about the destination MAC address, so that the destination will be identified by network components to deliver it. So now, since switch noticed that the packet got delivered successfully to node number 2, it's going to take a record of it. Node number 2 and its associated MAC address. Similarly, in future, say that node number 1 wants to send data to node number 3, switch is going to broadcast it to all the nodes, but it notices that only node 3 received the packet, so it keeps a note of node number 3 and its MAC address. In future, if node number 1 sends a packet to node number 3, the switch is not going to broadcast. Instead, it's going to take a look at this table and notices that it already has a record of node number 3 and its MAC address. This MAC address will match with the MAC address in the packet, and now switch will directly deliver the packet to the intended destination. This is very efficient, and certainly this would eliminate the problem of excessive bandwidth we have with the hub. Added to that, switch uses a mechanism called full duplex, meaning it can send the packet as well as receive the packet simultaneously. So there is no problem of network collision as well. So clearly switch is a better alternative compared to a hub. Now let us talk about something called a router. Whatever we have talked about so far is local area network, and we're not connected to outside world. How do we connect to outside world? Or in other words, how do we connect to internet? It's by using a router. Router is actually going to act like an enabler for a local network to connect to outside world, the internet. Router will also help us connect to other local area network residing in a different subnet. Now let's say that you wanted to send data from node number 1 from LAN to say node number X in internet. This time the packet must have information about the destination element IP address or internet protocol address. Unlike a MAC address, IP address is a logical address, whereas the MAC address is a physical address. MAC address is useful only within the local network that you have. But if you wanted to send data to an element outside your network or to a device in the internet or in another LAN, then you're going to have to use an IP address, and you need to include that information in the packet. Well, when I say you need to include, you don't have to. It will all be taken care by the network. And so based on the internet protocol address, the packet will be delivered by the router to the intended node in the network. We'll know more about IP address when we understand DNS servers, client-server architecture, etc., which will come in our future videos. So to conclude, each and every device is going to have a MAC address, which is a physical address, and an IP address, which is a logical address. IP address is used to communicate with the node outside the network, and whereas MAC address is used to communicate, send or receive data within the network. Switch and hub are the two primary components used within the local area network to deliver the data within the network. But if we want to communicate with outside world, router is going to do that job of enabling our network to communicate with outside world, internet, or with other LAN network residing in a different subnet. Hope that makes sense. See you in my next video.